So let's take a look at Achieve section 3.7, number 7. Actually, a really quick one here. Just use the chain rule to find the derivative of this function. Y is equal to e raised to the 2 times x to the 9th power. Okay, so several ways of going about this, but using the chain rule, you should identify that the outer function is y equal e to the u, where the inner function u is 2x to the 9th, right? 2x to the 9th is inside, we say, the exponential function e to the u. Now, I'm going to use this Leibniz notation for the chain rule. The derivative of y with respect to x is the derivative of y with respect to u. This is the derivative of the outer function in this case, right? Of course, dy du, if y is e to the u, dy du is just e to the u, right? The derivative of e to the u with respect to u is e to the u. That's the derivative of the outer function times the derivative, what? Du dx is the derivative of the inner function, right? Inner is u equal to 2x to the 9th. So the derivative of u with respect to x, pull the 2 out as a constant multiple. Derivative of x to the 9th is just the power rule. Bring the 9 down, times x to the subtracting 1 from the power 9 gives me 8. 2 times 9 is 18, so I get 18x to the 8th. So it's e to the u times 18x to the 8th. Of course, e to the u, we don't want to leave that as e to the u. What is u? U is 2x to the 9th. So it's e to the 2x to the 9th power times 18x to the 8th. I just brought that in front. So there is the derivative very quickly using the chain rule. So in general, when you're taking the derivative with respect to x, say, of e to the u, where u is some function of x, here it's 2x to the 9th, but it could be any function of x, could be sine of x, could be square root of x, can be whatever. Then by the chain rule, derivative of the outer function, e to the u, times what? The derivative of the inner function, du dx, sometimes called the generalized rule in this case, but it's just the chain rule. And so hope this helps on this one. And if you have other questions about this one or others, please let me know.